Hello everyone, this is Krishna, roll number 20951A2130, branch aeronautical engineering. So today I want to discuss about design process of an axial flow compressor. An overview: introduction, construction, working, design, applications. Introduction: an axial compressor is a machine that can continuously pressurize gases. It is a rotating airfoil based compressor in which the gas or working fluid principally flows parallel to the axis of rotation. Axial flow compressors produce a continuous flow of compressed gas and have the benefits of high efficiency and large mass flow rate, particularly in relation to their size and cross section. They do, however, require several rows of airfoils to achieve a large pressure rise, making them complex and expensive relative to other designs. Axial compressors are integral to the design of large gas turbines such as jet engines, high speed ship engines, and small scale power stations. Introduction: they are also used in industrial applications such as large volume in air separation plants, blast furnace air, fluid catalytic cracking air, and propane dehydrogenation. Due to high performance, high reliability, and flexible operation during the flight envelope, they are also used in aerospace engines. Construction: axial flow compressor consists of casing fitted with several rows of fixed blades and several rows of moving blades which are attached on a rotor. The fixed blades are placed on alternative rows. The fixed blades and moving blades are all as possible for efficient flow. The one set of rotor blades, one set of starter blades called stage. The number of stages in axial flow compressor depends upon pressure ratio required. Usually 5 to 40 stages are used. The length of blades is reduced in direction of flow to compensate for the reduction in volume resulting from the increased pressure. The blades are also so arranged that the spaces between blades form diffuser passage and hence velocity of air is reduced as it passes through them and pressure increases. Construction: axial flow compressor is also high speed machine and speed may even vary from 10,000 to 30,000 rpm. Generally, maximum pressure ratio achieved in a stage of axial compressor is about 1.12 to 1.2. Hence, to obtain pressure ratio of 12 attainable by axial flow compressor, 15 to 20 stages are required. As the fluid enters and leaves in the axial direction, the centrifugal component in the energy equation does not come into play. Here, the compression is fully based on diffusing action on the passages. The diffusing action in stator converts absolute kinetic head of the fluid into rise in pressure. The relative kinetic head in the energy equation is a term that exists only because of the rotation of the rotor. The rotor reduces the relative kinetic head of the fluid and adds it to absolute kinetic head of the fluid. That is, the impact of the rotor on the fluid particles increases its velocity. It is absolute and thereby reduces the relative velocity between the fluid and the rotor. In short, the rotor increases the absolute velocity of the fluid and the stator converts this into pressure rise. Designing the rotor passage with a diffusing capability can produce a pressure rise in addition to its normal functioning. This produces greater pressure rise per stage, which constitutes a stator and a rotor together. This is the reaction principle in turbo machines. If 50% of the pressure rise in a stage is obtained at the rotor section, it is said to have a 50% of reaction. Design: the increase in pressure produced by a single stage is limited by the relative velocity between the rotor and the fluid and the turning and diffusion capabilities of the airfoils. A typical stage is in a commercial compressor will produce a pressure increase of between 15% and 60% at design conditions with a polytropic efficiency in the region of 90 to 95%. To achieve different pressure ratios, axial compressors are designed with different numbers of stages and rotational speeds. As a general rule of thumb, we can assume that each stage in a given compressor has the same temperature rise, that is delta T. Therefore, at the entry temperature T stage to each stage must increase progressively through the compressor, and the ratio delta T by T stage entry must decrease, thus implying a progressive reduction in stage pressure ratio through the unit. Hence, the rear stage develops a significantly lower pressure ratio than the first stage. Higher stage pressure ratios are also possible if the relative velocity between fluid and the rotors is supersonic, but this is achieved at the expense of efficiency and operability. Such compressors with stage pressure ratios of over 2 are only used where minimizing the compressor size, weight, or complexity is critical, such as in military jets. Applications of axial flow compressor: blast furnaces, air separation plants, feed catalytic cracking units, nitric acid plants, jet engine test facilities. Conclusion: an axial flow compressor compresses its flowing working fluid by first accelerating the fluid and then diffusing it to obtain a pressure increase. The fluid is accelerated by a row of rotating airfoils or blades, the rotor, and the diffused by a row of stationary blades, the stator. Thank you.